Hello. Hey guys, can you hear me? Just confirm in chat window if you can hear me, guys. All right. All right. Hey everyone, welcome to yet another live stream. Today we'll be solving few more graph problems. Let's see how much embarrassing it gets today. Yesterday we solved three problems, easy, medium, and hard. The hard one really took us a lot of time, but I had a great time. I learned quite a lot. I hope you also learned something from that one. Today also we'll be solving few more graph problems. Again, you can also, I would highly encourage if you can also open your laptops and solve with me. So I'm going to paste the Discord link in the chat window. Make sure to head over to Discord because I'll be pasting the problem links over there. All right. And let's get started. All right. So I hope my screen is also visible, and let's go to the problems. We'll be solving more graph problems. All right. Let's see the next one. So I'm going to paste this problem. The like ratio is also pretty good. So I'm going to paste this into Discord. First problem is this one. I'm pasting it in the chat window as well. If you're not on Discord yet, you can directly see the problem link here. All right, let's see the problem. We are given a directed acyclic graph with n vertices numbered from 0 to n minus 1, and we have an array of edges. All right, and we have to find the smallest set of vertices from which all nodes in the graph are reachable. Okay, it's guaranteed that a unique solution exists, of course. So basically, we are given a graph like this one, and the output for this is 0, 3. Why? Because it's not possible to reach all the nodes from a single vertex. From 0, we can reach 0, 1, 2, and 5. And from 3, we can reach 3, 4, 2, and 5. So we output 0 and 3. All right. So basically, we are given a graph, and we have to tell the smallest number of nodes that we need so that if we start a DFS traversal or a traversal from them, we can ensure that each and every node in the graph is visible. All right. In this case, if you pick node 0, it automatically guarantees that you can visit 0, you can visit 1, you can visit 2, and you can visit 5. But 3 and 4 were still not like they were still not like you could not visit them. So you need more nodes. So you could have added 3 alongside with 0 because now if you do the traversals from 0 and 3, you can basically traverse to all the nodes in the graph, right? So for this one, for example, in this graph, you definitely need 0 because there is no node which is pointing to 0. So you definitely need 0. You need 3, you need 2, and then 1 and 4 will automatically be visited, right? So 0, 2, and 3. All right. Okay. Cool. This makes sense. Um, let's quickly think what we can do. I think it's quite straightforward, and this is like I think the problem is exactly same to the one I solved 2 days back in the video in which Gaurav had challenged me. It's exactly based on the same principle that if you want to make sure that you're visiting all the nodes in your DAG or directed acyclic graph, to do that, you always need to pick those nodes which are having no incoming edges. In this case, 0 and 3 are never having incoming edge. So if you do not pick them, no one can visit them, right? The other good thing is if you pick all such nodes, it will always ensure that all the nodes are being visited. It will always ensure that let it be any node, it can be present in any section of the graph, it doesn't matter. as long as we are picking all the nodes which are having zero incoming edges. They are only having outgoing edges, right? We are picking such nodes. And if we do a traversal on such nodes, each and every node from your graph will be visited. And I had proven this with a contradiction. I'm happy to do it again, but I think it's quite straightforward. Like since since there is a node which is not being visited, even like you had picked all the nodes with zero incoming edges and you're doing traversal on them, and if there is still any node which is not being visited, then how is it possible? Is it having any incoming edge? If it's having, then the node just behind that would be visited, right? If that's visited, then this node will also be visited. So by contradiction, you can prove that there is no such node which will not be visited. The only way that is possible is if that node is not having any incoming edge. But we are already picking such nodes in our initial set of the nodes, right? So that's how by contradiction you can prove that if you pick all the nodes which are having zero incoming edges, and if you do a traversal on them, your all nodes of the graph will be visited, right? So now it's quite straightforward, right? We have int n and we have vector of int. Let's make the screen a bit bigger. All right, so what do we have? We have edges, and so for auto e n edges, or let's use edge. So what can we do from the edge? We can say that int u is edge 0 and v is edge 1, right? And this is a edge from u to v. This is directed, which means that incoming v plus plus, right? What is incoming? It's a vector of int incoming, which is initialized to 0. And as we are processing edges, we are making sure that we are processing the incoming array correctly. So that later on, incoming v will tell us how many incoming edges does a node have. Okay. Then we can say int nodes with zero incoming edges. What do you want to call it? Let's call it answer for now. But this is basically number of nodes with zero incoming edges. So that can be quite straightforward. Okay, so we are having zero-based indexing, I think, right? Yeah. So let's use 0, I is less than n, I plus plus. And now we can say something like answer plus equal to incoming I is equal to 0. Return answer. So if incoming I is 0, we add 1 to answer. You can write it like this, or if you want to write it like this, you can do that as well. Same thing. So if incoming I is 0, then it means that node was not having any incoming edge. So answer plus plus and return answer. So this looks like it's going to work. Let's try to run the code. So this was not a medium problem, I feel. I have a problem here. So what do we have? Okay, so we have to return the vector. Okay. All right. And what we can do is basically do we have to return this in ascending order? Okay, so we can return the verses in any order. So this looks good. Yeah, so Vishnu is saying in the chat window that this is the same kind of problem um, that I solved 2 days back. Yeah, that's correct, as I've said. What is the time complexity of this? So we are using extra space. So this is space complexity, order n extra space. And then over here, number of edges this is order m, where m is number of edges, where m is number of edges. And then this is again order n. So the time complexity is order n plus n for this one. So this is, if you were using maps over here, this operation might have become order log n if you use maps. So it's not needed. So let's just avoid that because we don't want to add an extra time complexity. So the overall time complexity becomes order n plus m in this one. Cool. So this was definitely not medium, but easy problem. Let's look at sort integers by the power value. Do you want me to, do you want few seconds to have a look at the code or ask anything? I'm looking at the chat window, so if you want to ask anything, feel free to ask. All right, I don't think, I think everyone got this. This was trivial problem. All right. So let's move on to the next problem that we have. Sort integers by the power value. This is also having okay-ish likes and dislikes ratio. So let's solve this. I'm pasting that in the Discord as well as in the chat window. All right, let's see what this problem talks about. So the power of an integer x is defined as the number of steps needed to transform that given integer into 1 using the following steps. If x is even, you do an integer division by 2, and if it's odd, you convert that into even. So this will be an even number, or it can be odd also depending on x, right? Yes. Okay. So this can be odd or even. It will basically move around. It can be odd, even, anything. Okay. So we either multiply or we divide. Okay. For example, if x is 3, it's odd, so you make it 7. Uh, okay, so the power of x equal to 3 is 7 because it needs 7 steps to finally reduce into 1, because 3 becomes 10 because it goes into this second rule. Now 10 is even, so you divide by 2, then you multiply by 3 and add 1, and then you divide by. Okay, so this is a power of 2. Once it comes to a power of 2, we know what's going to happen. Okay. We are given three integers, low, high, and k, and the task is to sort all the integers in the interval low to high, inclusive range. So make sure that you understand what this means, right? Generally, if you want to talk from math perspective, I'm just going off the topic, but I feel that it's quite meaningful to talk about this. Um, so when you talk about ranges in general, what happens is there are two kind of ranges, inclusive, and then we have exclusive. What inclusive means is it uses these brackets, okay? And exclusive uses this bracket. So when I'm saying something like 1, 2, 3, this only means 2 if you're talking about integers. Or if you make this 5, it's talking about 2, 3, 4, and 2, 3, 4. However, if I make this something like this becomes 1 is inclusive, okay? So I just feel that you should know this. And to communicate this into English, we use the words like inclusive and exclusive ranges. So what we have over here is an inclusive range of low to high. And we have all the integers from low plus 1 up to high. And then we have to sort them in ascending order by the power value of each number. And if two or more numbers are having the same power, then we basically give preference to the smaller number first. Okay. We sort that in ascending order. So if, let's say, 3 and 13 are having the same power value, 3 should come first because 3 is smaller than 13. Okay. Now what do we have is we have to return the kth integer in the range low to high sorted by the power value. Okay. Notice that for any integer x in the range low to high, it is guaranteed that x will transform into 1 using the steps, and that the power of x is okay. So basically what it's saying is it's saying that you can assume and it's guaranteed that all the numbers will eventually reach 1, because it might look like that this process can go on over and over because we are also multiplying by 3, right? And here we are dividing by 2. But eventually what's happening is this transformation of numbers, it's a cycle, and it's basically going to it's not a cycle, sorry, but it's a series of steps, and eventually it will reach a power of 2, and then you will continuously divide by 2 and eventually reach 1. So that's what's happening. That's what it looks like from the question. It would be really cool to prove why that happens, but that's not something what it's not needed right now. All right, so just to take an example, if we have numbers from 7 to 11 and it's saying k equal to 4, So it's saying that the power values for all these five numbers is this. So you have to now sort based on the power values. So 8 will come first. Then we have 10 because the power value of 10 is 6. Then we have 14. 14 corresponds to 11. So that's why we have 11 and so on. And since k was 4, we want to return 7. All right. Now, okay. So the numbers are in the range up to 1 to 1000 and case, okay. So case, of course, corresponding to the rank, right? What number we want. So it's in the range of 1 to high minus low plus 1 because we have these many numbers. Cool. Let's see. So what do we have? The function is get kth, low, high, k. Um, I mean, we can basically, I'm sensing that we can use memoization over here. Like if let's say you are calculating the power of 7 or let's talk about longer numbers. If let's say you're calculating the power of 178 and let's say you're also calculating the power of 239. I'm just taking random examples, but what I'm saying is when you are calculating the power of these numbers and you are doing these transformations based on these rules, whether the number is odd and even, it might happen that these numbers hit a common endpoint. Like for example, it might happen that both of them reach to, let's say, 380, right? Both eventually meet at 381. Let's just say. So now what I'm saying is if we use memoization, what I would do is for each number, I'm going to store how many steps does it need to get to 1. Then what I can say is if 178 took, let's say, X steps to reach 380, and 239 took Y steps to reach 380, then 178 will take X plus steps of, and let's say 380 takes, let's say, Z steps to reach 1. So if I know this information, and when I'm doing the computation for 178, I can stop at 380 and I can find the answer or the power of 178 by the formula x plus z. And this can be simple as y plus z, right? Instead of, computing the power of 380 again and again, we can reuse that. So that's what memoization is also, right? So let's see. Let's have something like let's play safe and go to something like this int power value. So let's use power, and what we can do is int get power of a number n. It will be something like if n and 1. So this is if it's odd, right? So this do something, else do something. So we'll figure this out later on. But now what we can do is let's build an array for int I equals low, I is less than equal to high, I plus plus. I'm building an array of numbers from low to high. So add dot push underscore back I. And now I'm going to sort this array by using a comparator function. And that comparator function can be something like it takes two numbers, x and y, and it returns, so basically it computes the power, right? So let's do it like this. So power of x is get power x, and power of y is get power y. And now what we can do, let me think. So if the power is same, we return x is less than y because x is, no, right. Yeah. So if the power is same, I'm doing the comparison of their numerical values. And if the powers are not same, then the number with smaller power should come first. So using this comparator function, I am ensuring that once I sort the array, I am basically sorting the array in terms of their power values, and power values is optimized, it's memoized. It's not currently memoized, but I will implement that later. And then finally, I can return array of k minus 1, right? So this is what the overall idea is that I'm proposing, and I'll quickly check in comments if anyone is having any doubts. All right. So what we can do is basically um, if power of n is not zero, it means that we have already calculated it. So let's return power of n. Else, we can do something as simple as if it's odd, return 1 plus get power of 3 star n plus 1, right? Now, one question that we should ask over here is this going to basically reach? So basically, when you are multiplying by 3, is there any possibility that it becomes so huge that the number exceeds this 10 to the power 5, right? So this is something that we currently do not know, but yeah, that's something that we should know. So it's better if we use a map instead of using something like this. What I'm trying to say is we can use something like unordered map over here. My laptop is freezing a little bit. I'm not sure why. I'll quickly take a break and fix my laptop once. Let me just solve this problem and I'll take a break to, my laptop is having some, like maybe it's overheating or something, but yeah. So if it's even, return 1 plus get power of um, n by 2. Man, it's really hanging quite a lot. I think I'll proceed with the break once. Let me fix the streaming issue and I'll be back. All right, guys, I am back. Um, I hope you guys can hear me well. All right, so looks like you can hear me. I think the light went off, so I have just a single monitor. So let's make progress with this, no worries. So I'll be starting again the live stream. Just give me a second. All right, guys, hopefully you guys can hear me now. So yeah, where were we? Um, So you want to get the kth number. For that, we are basically creating the array, sorting that, passing the comparator function. The comparator function is computing the pass. If that's equal, we are doing the ascending order based on numerical values. Otherwise, the ascending order of power values. The power function is recursive function. If we have already computed it, we return that. Otherwise, before returning, we can also store it and then return. So this is like two statements in one line. What essentially is happening is before returning the value, I'm also storing it so that later on, if there are two invocations, let's say 178 and 239, even if that happens, it's quite easy for me to, like when there is 380, if I have computed the result once, I will simply return it from this line. The base case is important. The base case can be if n is 1, return 0, right? So this is how it should work. Let's try to run the code once and see if it's working fine. Okay, so as I was saying that let's make this power. So I'm converting that into an unordered map. So the lookup will still be order 1. And the reason I did is I do not know yet how big n can be. I haven't done the math. I haven't done that analysis yet. So just to save myself that it can be any int, it can be as long as it wants. They are already giving us this assumption, or they are guaranteeing that it will fit in 32-bit signed integer. So just to uh, basically save myself from the trouble of segmentation fault, I'm using this unordered map. It makes my life easy. So let's try to see if this is working fine. So this seems to work fine for 12, 15, and 2. Let's try to submit this. And it's working fine. All right. So basically, I don't see the application of graphs over here. This was a recursive solution. Um, if we deliberate, since we are like, basically, I don't know like why this was categorized as graphs. Maybe there is some solution which uses some graph concepts to solve this problem, but I don't see it's necessary over here. Like probably we can go to the discuss tab and see how people are proposing using graphs. But before we do that, let's give 2 minutes and see if we can figure this out. All right. Now, since I do not have my secondary monitor, there is power cut, and unfortunately, I do not have that on inverter yet. So I'm gonna go to the so basically this is like how I see this. Yeah. So this is where I can see all of you guys. Any doubts? So someone is asking what would be the space complexity? That's a very good question. Let's have a look at the space complexity once. So if you are talking about space complexity, let's see what's going to happen. Hmm. We are creating an array of size. So let's say if the number of so basically the range of low and high can be up to 1,000. So up as long so basically let's call that n. n is um, basically high minus low, right? So let's call that n. So we are using order n extra space over here, right? And n is basically telling how many numbers we have. Now we are doing a sort. So this is n log n time. This is order n extra space. Sorting takes order n log n time in general, but we also have a comparator function. And to compute the power of numbers in the range. So now, as I'm saying, like um, it might look like this memorization will be really good, and we might. So basically, I feel that this won't add any overhead, even if you compute low and high. I feel that it might be in the range of order n again, and overall amortized time complexity still stays at order n log n time. But having said that, I need to do more math and figure out what can be the upper range for this um, number, right? Because it was odd, right? And multiplying an odd number by 3, it makes that odd again. And then adding 1 makes it even. So I'm definitely sure that once we were over here, like if our current number was odd, this step is guaranteeing that in the next step, it will be even. So it looks like it's being multiplied by 3 and it can, explode, but it's not going to happen because we are multiplying by 3, but then we are also dividing by 2, right? And after division by 2, if basically it's still having a power of 2 in it, basically if it's still even, then we can do another division by 2, right? So that's what I'm trying to say. Like over here, we had 3. 3 will all, so basically whenever you encounter odd, the next number will always be even. So it might look like from 5 we are going 3x to 15, but it's actually 1.5 times because we are again going to divide by 2. So we do have an amplification factor, but that is bounded by 1.5. That's the first observation. But again, how long can it go? I feel that it might not go that high. So overall, I would say that with certain degree of assumption, I would say the time complexity is order n log n time because I can compute, this can be done as pre-computation. I can do this for the first, let's say, first 2 in numbers or first 3 in numbers, if you understand what I'm trying to say. But yeah, I mean, I might be wrong because I would need more time to do this. Like to give justice to this, I need more time. That's what I'm trying to say. But yeah. So yeah, order and extra space. Again, the recursion. One other thing that we have to keep in mind is if you remove this, it's not true that you have just order one extra space. You're not using constant space because you're using recursion over here. Had you been using iterative solution, right? If you were using that, because you can do that as well, right? You can run a for loop and compute using iteratively. But if you are using recursion over here, so the stack depth is also something which will be counted in the extra space, which can be log n, I think, in this case. But so that's what I'm trying to say. We are already using order and extra space, so that recursive depth doesn't matter. But if we were not using that, even then we cannot say that it's constant extra space. We were anyways using order in extra space, order log and extra space. All right. So do you have any doubts or something like that? Does it make sense? All right. Cool. Do you have any suggestions on how to do this using graphs? I think we can do something like BFS. BFS traversal might play some role because what essentially happens is you can think of this as like transforming x into this even number. It's simply a edge from x to x by 2 or from x to 3x plus 1. So you can think of it like a graph as well. And eventually all the nodes are converging at 1. And the power of a node is basically the number of edges it needs to reach the node 1. So you can think in terms of graph as well, but I don't really see any value. But let's have a quick look at a hint. So as it's also using dynamic programming to get the power of each integer. Again, man, the hints given in this lead code problem is exactly what we are doing. So I don't know why they tagged it under graph, so I'm going to give this a dislike. It doesn't make sense. Um, the tag graph seems misleading. Or shall we, like, I think there can be other solutions in the discuss tab which use graph to solve this. Let's see if we have something. All right. So it can be. Okay. So someone is actually asking why is it tagged with graph topic? Um, so let's have a look. Okay. So there is only one comment, and that's also like it is wrong. Ah, okay. Oh, okay. So we do have something over here. So we have something like Collat's conjecture, which is again this formula f of n. It converges to n by 2 if n is even. And I'm just going to make my screen a bit bigger. And otherwise, it is 3n plus 1. Okay, so we have some graphs over here, I feel. Interesting graphs. Right. Yeah, exactly. I think this is what I was trying to explain you guys. Like we can think of, these transformations as being mapped from node x to 3x plus 1 or x by 2. So that's exact, and every node is eventually converging to 1. That's what's happening. And the power of any number is the number of steps from that node to 1, right? But I don't think like why do we need to complicate this? It's good to know Collat's conjecture. I have not read about it, but yeah, it's something that if you want to read, feel free to go ahead. I don't want to, do this in live stream. All right, cool. Let's move to some other problem. Let's do this one. Regions cut by slashes. So we have, I will say, okay-ish number of likes and dislikes. Let's quickly read the problem. The problem is saying that we have an n cross n grid composed of 1 into 1 squares, where each square is either this or that, or a blank space. These characters divide the square into continuous regions. Given the grid representing a string array, return the number of regions. I mean, what is the problem? An n cross n grid is composed of 1 cross 1 squares. Okay. These characters divide the square into continuous regions. Given the grid, return the number of regions. Okay, so this means that, I mean, I'm not getting like what is the format given of the input problem? Okay, so it's having a blank space and oh, okay, I see. All right. Okay, so this was a space. I did not read that. Like this is really confusing, but yeah, if you can see this, this is a space that we have over here. And the problem is basically, okay, the region is 1. Over here, the regions are 2. Oh, interesting. Here, the regions are 4. Ah, I see. This is nice. Um, so how have they computed this graph? Like, okay, so it's 3 cross 3. And in first row, we have like, I don't think how is this picture related to this example. Recall that because these characters are escaped. This refers to this. Oh, they are also doing escaping of characters. Oh, okay. Ah, I see. So I think the dislikes are because of this only, but the overall problem is good. I'll quickly paste the link in the Discord as well. Um, where is the Discord? All right. Third problem. Any issues in the stream? Is anyone having any questions? So this is the third problem that we are going to solve. Yeah, someone pointed a good thing that in the previous problem, which was about sort integers by the power value. We do have space for the unordered map as well. So that's also going to take order in space. I'll quickly show what it means. So this unordered map, right? It's having order one space. Sorry, it's not taking order one lookup, but order in extra space, right? And this n can be again like how many different numbers do we hit in doing those transformations from x to x by 2 or 3x plus 1 and so on. So this also takes that one space. At least order and extra space is also needed over here. Cool. Let's move on to the problem that we were having. So what they're saying is basically, let me show by code. Actually, that is more meaningful. So they're having a grid, right? And it's a vector of strings, and n is nothing but grid dot size. And now we can say like for auto row in grid. So now over here, what they are essentially trying to say is in C++, they are saying that in strings, because the backslash character is escaped, so we have to place double backslashes in order to treat that as a single backslash. Um, and over here, the grid size is actually 2, and the first one is a backslash, then we have a forward slash. And again, the grid size is 2 over here. And over here as well, we have a forward slash and then a backslash. Because backslash needs escaping, we have double backslashes. It's actually good to see, first of all, how does C++ treat this? I'm hoping that there is no lag in the stream now, guys. From here, I can see there is excellent connection. So, but in any case, if you feel, please let me know in the chat section that there are some lag issues or something. All right. So, how many sections does it have? Okay, so this is interesting, right? This is actually an interesting problem. Uh, let's see. So this one is having 5 sections. Um, it's again having two. It's a grid of 2 cross 2, right? Yeah, man, this is interesting. Yeah, let's try to solve this problem, guys. This one looks a good problem to me. So the idea that I'm having overall is I need to do a DFS traversal and I need to count how many DFS traversals I need to perform on the grid until I visit everything. And the number of DFS is basically telling me the number of components in this graph. So think of this as a problem of graph in which we are supposed to count the number of connected components that it has. So this is one connected component, this is another one, this is another one, this is another one, this is another one. So that's why we have 5. In this one, everything is a single component, everyone is connected. So we have to be really, we have to be really sure in basically assessing how many components we have in this graph that we have. So this one, the answer is 3, and it's a grid of 2 cross 2, right? So we have double slashes and then one slash and then we have nothing. And this is really good problem. Let's try to solve this. So So how can I, how should I proceed? Let me think. So we have a graph, and I'm using pen and paper. I recommend you also do that. And I'm just going to go in the chat and see if anyone is okay. So there are no lag issues. That's good. Someone is saying it's really a tough problem. So yeah, it's tough, but let's see. We will have fun. We will solve this. Let's see. Um, anyone, any more doubts? All right, let's see, guys. So it's a square grid, first of all, right? And we have to drag blanks as well in that. All right, cool. Hmm. The interesting thing is there can be components. So there is definitely boundaries happening at the end of the wall of the grid. We have components from there. We can also have components in between. So we just need to, we just need to understand how to process this graph correctly. If you do that, it's really, it looks easy after that. But yeah, it's a good problem. We should definitely solve this. Let's see. So let's say we have something like, right? So 2x2 grid. Um, so in this way, like when we are writing it this way, it's really like difficult, but this one over here and this one over here, both of these form a diagonal because of which it divides into sections. So that's what we were having over here as well. Um, yeah, this example is exactly this one. We have two forward slashes and then one forward slash and then a space. So this becomes this, right? And that's why the sections become 1, 2, and 3. All right. So this is going to take some time. Let's think. How should I process this graph? This is a good question, man. This is like really good if you ask this in a coding interview. I mean, it's really good in that sense. Um, mhm. Okay. I'm I'm thinking in the direction of, so how should I put it? So if you are seeing this figure, instead of looking at it as a 2x2 grid, I was going in the direction that, I treat these points as basically I'm thinking of treating them as a vertex. So this is one vertex, this is another, this is another, then this is another, this is another, this is another, and so on. So for a 2x2 grid, we have 9 vertices. And then what I'm thinking is, um, I make these edges, and when I have a forward edge, I connect these 2 points or these 2 nodes in the graph. Similarly, like initially, only we create the nodes, we create the edges for the boundary. This node will be connected to this one will be connected to this one, and then we'll go down. This one will be connected to this is connected to this, and so on. So we create the edges for the boundary, and then for any forward slash, we connect these 2 nodes. And then eventually what I'm trying to do is In that graph, I want to count the number of boundaries or the cycles that we have. But I don't want to overdo that. For example, if this is one cycle, this can be another cycle as well, but I don't want to count that. I want to count this as one cycle, this as another cycle, and this is the last cycle. Something like that. I'm going in that direction, if it makes sense. Did you get what I'm trying to say? Can you just let me know in comments if what I'm saying is making sense and you understood it? I had just asked in the chat comment if my approach is making sense, if you're able to understand what I was saying. Did you guys get my approach? All right. So a lot of people are saying yes. Some people are saying, can I explain my approach again? So what I'm saying is, because these strings are, it's really difficult to think of it as just an n cross n grid and think of it as n square points. Why? Because each point is having a string, right? It can be a blank or it can be forward slash or it can be backslash. So the problem with that is I really do not basically we are talking about regions and it's talking about areas. It's not talking about individual numbers if they are connected by, like, if they share a side between each other, they are connected or not. So that's why I'm trying to look at it from a bigger perspective. I'm trying to basically create virtual nodes. And what do I mean by virtual nodes? Initially, for like 2x2 grid, I will have I'm looking at it as I'm looking at it as a graph of 9 vertices. Each row is having 3 vertices. This is the first one, second vertex, third vertex, fourth vertex, fifth vertex, sixth vertex, and seventh, eighth, and ninth. Why I'm doing this? Because now I can think or process this much in a much better fashion. For the boundary, I can create the edges in these new virtual nodes that I have created. And then for every forward slash or backslash, I can basically, figure out what are the nodes that I have to connect. And once I do that, now the question is basically how many regions does this graph have? So it's not exactly the number of cycles because it might be like, as I said, this is one cycle, but this can be another cycle. So we don't want to count that twice. We want to count this as one, this as second, and this one as third. Something like that, if it makes sense. I'm 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 still not like the solution is not in front of my eyes right now, but this is something which is basically it's still better than what I was thinking before because this still enables me to think on top of it and figure out if we can solve in this way. I hope that makes sense. So let me move to my other screen. Yeah. So someone is saying in chat comments that um, if you encounter a space, put a dot in the grid. So they are saying that put a dot in the grid like this, and then simply count the number of islands. That doesn't make sense. Um, the problem is basically how do you, the main crux is basically, of course, we have to count the number of islands, but the main algorithm that this or the main thing that they are testing is how do we process this grid and create a graph that actually makes sense. Man, this does not look like a medium problem to me. It's really good. So basically, if you got what I was saying that convert 2 cross 2 into 3 cross 3 grid, and I was saying that this is how it looks like. And then I was saying that if we have a forward slash, I connect them like this, right? And we had another one, so we make it like this, right? And we had edges over here. So this is making much more sense to me than what we had originally in the question. And when we have a space, I don't do anything about that. And then I do this, right? So hopefully this is making much more sense. This is where I was proceeding. Something like this. So now what's happening is basically, I mean, this is really, yeah. So what's happening is this is one region, right? From these three axes. And then this is another one. Actually, I don't add edges over here. They are not having any edges. And now we can, see the regions in this as three. But it's like how to process this graph, because if you start counting the number of cycles, that is also not the right way to solve this. Um, okay. The problem is we can have sections coming in between as well. Like this section is like this was built inside the maze, so it's a real good problem, man. How would the graph of this one look like? Let's see if we can make some progress. Um, so let's take some space. So we have this. For a 2 cross 2 grid, we had these many nodes, right? So this was the maze initially, and now we had a forward slash here, and then a backslash here, right? So that's one. Then we have, I mean, really good problem. So you see the problem over here. So this is another region that is forming in between. Man, really good. So in this graph, how could I have figured this out? So this is one cycle. This is one cycle. No, man, cycles are not making sense. Cycles are not making sense. We have to do something else. So one thing is, if a node is having no edge, we can simply remove that. This looks much cleaner, right? But how do I find the number of sections? We do. I have studied discrete mathematics, and in that I do think we had some formula which I'm not sure if it was about number of cycles or something, but it was actually something like this only, which it basically associated number of edges and vertices, and using this information, it basically I think gave some number of uh, I think it was number of regions only, something like that. I'm not sure, or it was cycles, something like that. How do I search it? Like I studied this in discrete mathematics, I believe. Let's see. Discrete math, graph. Um, did I study it in discrete math or graph? I'm not even sure about. I think it was discrete math, but let's see. Graph theory, discrete math, um, number of regions, edges, edges and vertices, something like that. Yeah, maybe Euler's formula. Yeah, planar graphs, exactly, planar graphs. So what do I mean? Actually, I was not having the exact term to say this, but exactly that's what I was saying. We do want to count the number of cycles, and like this is not a very trivial graph. These graphs we can draw them beautifully on paper, and that's how I would define planar graphs, right? For example, exactly like this one. Yeah. Yeah, so there are no intersections of edges, and that's exactly what's happening. Like if you consider the picture on the left one, this edge and this edge, they are overlapping. We do not want that in planar graphs. If you can draw graphs like this, they are considered planar. Okay, so what is it saying? For any connected planar graph with v vertices, e edges, and f faces, we have v minus e plus f is 2. All right. Okay, so the number of faces is that number of regions. So let's see, in this one, we have four vertices and edges are 1, 2, 3, 4, 5, and 6. So 4 minus 6 um, plus f is 2, which means that this becomes minus 2, right? And then f becomes 4. And the number of regions are 1, 2, and 3. So what is face, first of all? We call each region a face. The graph above has three faces. 1, 2, okay. Oh, okay, so it's also including the outside region as one face, I feel. Okay, because this for this one, it's saying that the faces are three, so maybe one, two, and it's saying the outside area is also a face. Yes, we do include the outside region as face. The number of face does not change no matter. All right, maybe this is what we have to do in this one as well. Exactly. Like this is not planar, right? If you can see this one, it's impossible to, um, like even if you take this edge from outside and try to draw it, it's still not going to function. Like there will be at least two edges which are intersecting. So K5 is not planar. I have studied this. I did study this. This was an exception. Uh, this is discrete maths, right? Yeah, this is discrete maths. Yeah. All right. Uh, do we have any other examples for validation or something? So let's quickly see for this one, right? The number of faces are 1, 2, 3, 4, 5, and outside one is 6. And let's see if it's working fine. What was the equation? I mean, it would be really cool, if I also try to understand how to prove this because I love such problems. I love discrete mathematics a lot because discrete mathematics is about, um, uh, even that abstract algebra, it was super cool in which you are studying. So basically you proceed with that. You have assumptions on few, like for a given object, if it follows these properties, you try to derive so many other properties that given if it is following this, it's going to follow this, and this. So it's really, abstract, but super cool. I love that as a subject. So yeah, so the equation is, let me see again. V minus E plus F is 2, right? V minus E plus F is 2. So let's see if it's functioning for our examples. B minus E plus F is 2. So we can say F is nothing but um, E minus V plus 2, right? So in this one, let's see, number of edges is, so this is 1, 2, then we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges. The number of vertices are 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, and then plus 2. Now, this is not making any sense, right? 4 plus 2, this becomes 6. Oh, okay, it's working fine, right? Because it's also counting the outside region. So we have 1, 2, 3, 4, 5, and the outside one is 6. Yeah. So this does work, but given that we also want to consider this as a vertex, then the number of vertices will increase, the number of edges will not, right? So that's a problem. So we don't have to count such nodes which are having no edges. All right. So yeah, this can work, right? So the equation is a minus b plus 1. All right. So this is the final equation that we have to use. I'm putting it like this, right? V is not V is not all nodes. It's basically you have to remove the nodes with zero edges. We don't have to consider them. Only then this function, this formula will be working fine. So all right, so we have to make this graph, and then I did use Google. I did use Google. I admit I did use Google, but yeah. Um, so the idea is clear, right? I hope the idea is clear. I'm checking the comments. Let me know if this is making sense and you got what I'm saying, right? So we just have to create this graph. Um, do we really need to create the graph as well? Like, let's think for a moment once. Yeah, I think we do need, because we want to know the number of nodes with zero edges, right? So yeah, let's actually create the graph, or let's actually count the uh, the number of edges for each node. Let's do that actually. So someone is saying the given this someone is saying it won't work, something like that. I do think it will work. I'm not sure why, because I feel that the nature of the grid is always planar, because already your display, the input is itself in a string, right? So you can anyways draw edges without having intersections, because there is no X in the grid. There are always forward and backward slashes. So I do feel the formula will work. I'm not sure why it won't work. Someone is saying it won't work, but let's see. I'm taking my chances, because I believe that my analysis is fine and it's going to work. I may be wrong, but yeah, if it is wrong, then I'm going to end this, and I'm going to end this stream and figure out how what is the solution, do that homework, and probably make a video separately on that, because yeah, I do feel this is going to work, but let's see. So E minus V plus 1, we have to be careful in handling V. Um, so how should I write the code for this? So um, if yeah, so we have to allot meaning to nodes, right? So um, so this was my input. This is 0, 1. Let's actually write that 0, 1. Right? So how should I generate right? Um, So I'm just thinking, how should I, number or create this graph? So that should be an easy math. So basically what I'm saying is, if grid of ij is this, how do you process that? So we have to do numbering to these nodes. And when your grid ij is forward slash, what are the nodes, right? So an edge is a connection between u and b. So I'm trying to assign the values to u and b as a function of I and j. That's what I'm trying to do. All right. So let's see. It should be easy. So for So we already have our own nodes like this, right? So that is 0, 1, 2. And when we have 0, 0, so let's actually do it like this, right? We name these nodes as 0, 1, 2, 3, 4, 5, 6, 7, and 8. So 9 nodes we have. Now, since 0, 0 is a forward slash, it's connecting to 3, 1, right? So 0, 0 evaluates to 3 and 1. As you can see, this slash over here, 0, 0 position, it's connecting nodes 3 and 1. Similarly, 0, 1, this is evaluating to 4 and 2. Right? Yeah, I think I can see the pattern, but yeah, let's also do it. Uh, so yeah, I think I can see the pattern over here. So 1, 0 is connecting the node 6 and 4, right? Yeah. And if we had something over here, and these are for forward slashes only. So if this was a forward slash, we would have something like this over here. Backward slash would be different. We will come to that as well. But 1, 1 will connect the nodes 7 and 5, right? So that's what I'm saying. If your grid ij is forward slash, you need to find out the necessary u and v values. And if it was a backward slash, you have to find the necessary u and v values. You have to maintain the number of edges, which are you have to maintain the degree of each node, and we can find the necessary v, and then we can simply use this formula, right? So we are adding edges on our own. So these are the edges that we are adding on our own, two on each side, right? So for a 2 cross 2 grid, we add two here, two here, two here, and two here. So 4 times 2. So if a grid is n cross n, we are adding 4n edges on our own. So that's definitely there. And other than that, there are how many edges the grid has, that is also being added. And then we just have to count the number of vertices. And so basically this is the answer. And I'm trying to figure out how to calculate each component. I'm trying to see how to calculate E. I'm trying to see how to calculate V. And if I can do that correctly, I can simply return E minus V plus 1 and I will get my answer, right? So that's what I'm trying to do. Calculating E is easy. So given the input is this grid, I generate a new graph on my own. So I'm adding edges for walls also. So for a 2 cross 2 grid, I'm adding 8 extra edges. For a 3 cross 3 grid, I will be adding 4 into 3, 12 extra edges, because there will be like 0, then 1, then 2, then 3, right? So this will be there. And then we'll be having similarly over here, right? And then we will be having edges over here as well, right? So in all the 4 directions, in a 3 cross 3 grid, you have 3 edges. So that's why E is always 4n, where n is the size of grid, plus the number of edges in grid. So that depends on how many forward and backward slashes you have. That's also easy to calculate. V is basically, initially we were having, for an n cross n grid, we were having n plus 1 into n plus 1, right? These many nodes, but we have to minus the number of nodes with 0 incoming edges. So to calculate number of nodes with 0 edges, because it's an undirected graph. So to calculate this number of nodes with 0 edges, that's why I need to process this grid ij. If it's a forward slash or backslash, I need to figure out the relevant vertices in my graph and increment their counters of degree. And at the end, I can iterate on all my nodes, and I can find out if there are, and I can count the number of nodes with 0 edges, and I can basically, once I have E and V, my answer is this. All right, man. I think let's enough talk. Let's actually get in action. Like ij is forward slash. So let's actually understand it like this. For a given ij, I have inserted one row above. and right, yeah, right. So basically you are having 2 cross 2 grid, right? What essentially ij happens is they are incremented by 1 because we are adding 3 points here, right? So basically one row is added over there and one column is also added over here, right? That's what's happening, right? So let's see. So what I'm thinking is, let's do I plus 1. Uh, right, right, and j, right. Okay, right. So if my ij is a forward slash, then right now it's at ij and it's also going to the next row and towards the left hand side, right? Okay, makes sense. So how should I make this? Um, how should I process this? Let's see. What I can do is something like there. The next one will be I plus 1, comma j minus 1, right? Something like that. And this ij will also be incremented, right? Or I can take that as same. That actually makes sense. Yeah. So this ij eventually becomes I comma j plus 1. Yeah, this is making sense, I think. And the other node is I plus 1 comma j, right? I feel so. So let's take an example. That would be more easier. So for 0, 0, what this evaluates 0, 1. So basically, I'm trying to find the u and v for a given I and j in my original graph or in my original grid. So it becomes 0, 1 and 1, 0, right? Yeah. So this is 0, 1 and this is 1, 0. 0, 1 and 1, 0, right? Hmm. And what else? Yeah, correct. And this can be converted into, so basically in my new graph I can simply do n star I plus j or n plus 1 actually, right? This makes sense. Cool. So yeah, I mean I'm from a given ij I am finding ij plus 1 and I plus 1 j. These are the new nodes and I convert that into n plus 1. Yeah, so this is fine for that. And for forward slash, what's happening, let's see. When ij is a forward slash, sorry, backslash. So when this is a backslash, I think I comma j plus 1 will stay as it is. Or let me think. Or let's see. So had it been, if 0, 0 was having something like this, what would happen? This would be this, right? So I stays at same, j also stays at same. Okay, so I just stay at the same thing. And now we have the other one is I plus 1 because we are going one step down and then one step right, right? Yeah. So I plus 1 and j plus 1. This is what I'm thinking. So these are the u and v in my new graph. This is really confusing. Sorry about that. But yeah, let's see. Um, okay. So int edges is nothing but 4 star n, first of all. And let's use n dash or um, n plus 1, something like that. Or um, I mean, let's call it n dash 1 now, which is n plus 1, right? This is the like number of vertices in each row in my new graph. What number of nodes or points in each row in new graph? All right. So what do we do if row uh, again? Like we should actually iterate it in I and j. I is less than n, I plus plus. For in j 0, j is less than n, j plus plus. It would be really, it would be really sad if this approach doesn't work and we get wrong answers. But yeah, let's hope it doesn't happen like that. Um, so if grid ij uh, is a for if oh low battery, there. Let me just plug in my charger. I'll be back. All right, guys, I am back. Let's close this one. Where were we? If grid ij is this, um, we know that int u is f of I comma j plus 1 and v is f of I plus 1 comma j, and then we add an h. So basically degree of u plus plus and degree of v plus plus, right? I think my camera is off. I'll enable that. So what is happening? Just bear with me for a moment. Like basically you are doing this numbering, right? 0, 1, 2, 3, 4, 5, 6, 7, and 8 over here. So for a given ij, how do you get that numbering? That's quite easy, right? For given ij, how do you get the vertex number? So you can simply return I star n plus j. What is n? N is number of nodes in each row. So you have to know that value as well, right? Does this make sense? Yeah, I think it makes sense. Definitely it makes sense. So I also pass in n dash. I compute u and v. So that's exactly what I was saying originally also. For given ij, I want to figure out the u and v that I did, and I'm incrementing their degrees. All right, I have processed all edges. For each edge, I can do basically e plus plus. This is an edge. Similarly, if let's call this char c, if c was this, else if c is a backslash, again, this is another edge that you have to process. You find out the necessary same thing basically. What is happening? Yeah. So now we have seen that for this is ij and I plus 1 j plus 1. So ij and I plus 1 j plus 1. I have not verified this, but yeah, I am just making progress right now. And once I have done this, do we have something? Let's close this. There is some problem with the indentation. Sorry about that, guys. Yeah, it's better now. Cool. So what do we have done? Now we have calculated E correctly. We have calculated degrees correctly. The number of nodes int v dash is nothing but n plus 1 star. So basically int v dash, number of vertices in the new graph. It's n dash star n dash, right? It's a square matrix. And now what do we have to do? Basically, you have to do something like um, I is less than um, n dash I plus plus. So iterating on all the nodes of the new word or the new graph. And now if degree of f of I comma j comma n dash is 0, basically v dash minus minus. So this node is not there in our graph. And finally, if everything went correct, what will happen? We return Why is this indentation messed up? I don't know. Are we missing some bracket or something? This is really bad otherwise. I think it's fine. Yeah. So what do we have to return? Let's see. We have to return, where is the formula? A minus V plus 1. So A minus V dash plus 1. Okay, now before we move forward, let me see if this is actually functioning fine. Um, let's put in 0, 1 in this one, and let's see what's happening. For 0, 1 and forward slash, what happens is this becomes 0, 2. So yeah, this is correct, 0, 2. And then we have 1, 1, which is also correct. 1, 1 is 4, right? Yeah, this is correct. And had it been a backward slash, so let's make this a backward slash, something like this. So our graph would have become this. So basically this is 1, 1. If you plug in 1, 1 over here, we have 1, 1 and that is 4. And then this one is 2, 2. This, yeah, so this looks correct. Let's actually run and see if it's functioning fine. Okay, so what is the error? Missing character in this one. I didn't get. Ah, okay, so this has to be escaped. Um, so what is degree? Let's see. So what is the constraint do we have on n? It's 30. It is really very, very small. Let's basically we need something like 100. That would be fine. Oh, sorry, n square. Let's keep it at 1000. That should be enough, right? And let's have int degree n. Let's also do the initialization, just because we have seen last time also, like this is a class and they submit again and again. So we should also clear degrees out at the end. Let's actually make this a bit more readable because this was not readable. So ID becomes f of ij and dash. This is the ID or the node number in the new vertex. Node ID in new vertex. And let's actually do the, like once we know the answer, um, let's actually do it like this only, right? So we are doing clear the degree array for next run. DEC, wrong answer. Okay. Yeah, so definitely I'm not expecting that we will solve everything in the first go, but let's see what's happening. Let's actually do a debug of things. So in this case, what would happen? How many edges would we have? Let's see. Let's remove all this, right? So now the problem is saying we have an edge here, here. Then we have nothing over here. Then we have an edge here. Right? And then we have an edge here again. And something like this. Okay. So now for this one, what would we have? The answer is 2, definitely. And what is it that we have computed? Let's have a look. So okay, so this is again something that is not needed, right? So this this can be ignored. So this can be considered as something like this, right? That's why I think this is the problem in our current approach. So this is also that we have to handle. This is something like this. Had it been like this, what would be the answer? The number of edges are 1, 2, 3, 4, 5, 6. 6 edges minus 5 vertices plus 1. And now we would have returned 2. right? So we need a bit more handling for these edges, right? For this one, right? They are not playing any role right now. Mm. But I didn't count them. Uh, okay. So there are problems with my current code. I can definitely see that. I have not added edges, first of all. So that's one problem. But even if I add edges, that's going to increase my answer. So the number of vertices were not counted correctly, I believe. Or uh, no, actually, we were counting a lot of vertices. Yeah. So that's one problem, right? Yeah. Yeah, so I do need to add those edges. If I add them, they will also, the B will also reduce. Yeah. So that's one problem. Okay. Okay, so do we need edges over here? That's what I'm thinking. I think we can simply keep, I can simply increase the degree of all these one. Yeah, I think that's something that can work. Right, right. So yeah. Let's try to do that. So what I'm saying is, um, so for 2 cross 2, what are the IDs for the end one? So this is 0, 0. This is this one. The rightmost edge will be 0, comma n, right? Or n dash minus 1. Then this one will be n dash minus 1 comma 0, and the last one will be n dash minus 1 n dash minus 1. So basically what I'm trying to do is making, I have not yet created the edges for the boundaries. So that's what I'm trying to do. I'm trying to create the edges on the boundaries, and let's see if that fixes the problem for us. I do feel it can, right? Yeah, it might solve our problem. Let's try to see. So let's copy this over here. What I am trying to do is degree of f of plus plus. But actually, let's do it in a more better way. So vector of pair of int comma int. Let's call it corners. So for corners, it will have a list like this. So let's create the corners. I just hope this works, because I have certain confidence in this approach. It might be having few corner cases that we have to cover, but yeah, I do feel this problem, like, first of all, this problem is phenomenal. I really am enjoying solving this. But now what I'm saying is, for auto corner in my corners, I can say degree of what is the ID? And ID is nothing but f of c0, c1, and n dash. So I get the ID and degree of ID plus plus. Cool. Uh, let's see if this works. What is the problem? Okay, so this is uh, okay. So I don't think we can do something like this. Oh, silly mistakes, guys. Damn it. Anyone having any clue what we are doing wrong? Yeah, I did handle so someone is saying we have to do the subtraction for universal phase. I have already done that. Let's actually debug things out. What's happening? Let's see. Why are we getting 6 as the answer? Let's see. Um, I'm thinking let's do it like this. Let's print every edge that we are going to add. And so this will test whether we are adding edges correctly. So that's something that we should test if edges are being added correctly. And then over here, we should also see if we are adding corners correctly. I'm not sure if this approach is fine, first of all. So corner ID, right? Um, let's see once. Okay, so the number of edges, yeah, so that this is also wrong then. The number of edges should also be wrong. Yeah, man, this is wrong. It's better to not count it like this, actually. Yeah. Damn it. So there is just this problem of, initializing them correctly. And the problem right now is this is too granular. Like in this one, you are adding unnecessary graphs. So these edges are not needed, basically. That's what I'm trying to say, right? You can remove this. So when you're removing this, your V reduces. But I think this is still not having any problem because, if you remove this vertex, if you remove this vertex, you are reducing V by 1, but you're also reducing E by 1. Initially, they were having 2 edges. Now there is 1. So removing this is not basically causing any problems, right? Yeah. So actually do this for all the outlining only. So let's do this. We will add edges for all the outlines. So all this outline will have a degree. So let's do that. We haven't done that because right now. Um, yeah, I think that's the main problem. So what I can say is I don't need this right now. Sorry about that. But what I can do is iterate in all these 4 directions, something like that. So for int I equal to 0, I is less than n dash, I plus plus. So let's iterate on the top row. The ID for that will be top row means this is 0, right? Then this is I, and this is n dash, and degree of ID plus plus. So once we do that, next time, so this is for the top row. Now we can do for this one. Again, we have endpoints over here, but this one, the ID will be nothing but n dash minus 1, the last column. The row can be this. The column is fixed, and then n dash, and then degree of ID plus plus. So these edges have been handled, these have been handled. And similarly, let's move on to the next ones. We will be trying to do this again and again. So let's paste this twice. So this one was for top, this one was for rightmost column. Now let's do for um, the bottom row. So for the bottom row, this is n dash minus 1, and this will be I. And then for the leftmost row, leftmost column, sorry, the rows will be iterating, and this will be 0, right? So now, basically, I hope this, now we are getting somewhere, right? We do not need this corner print statements. Um, what do you think, guys? Would this get accepted if we now submit this? Let's see. We are getting wrong answer. Damn it! And it's just 1. Is this approach really messed up, or are we having some problem in the code? What do you think, guys? So this is 4 cross 4. I mean, it will take me a lot of time to debug this out, but yeah. Is this approach flawed or not? I mean, I'll work on this, but I do feel the approach is not wrong. Maybe there is some problem with the implementation, I feel. I do feel the approach is fine. And so it's good that we already have a sample case in which it's not functioning. If anyone of you can see the problem, it's fine. Otherwise, I'll have to end the stream. But I will definitely cover it in a separate video. So yeah, let me know if you feel like there are two things. The approach is not right, which I doubt. I still feel the approach is right. So there is some problem with the implementation. So in any ways, I'll be uploading all these to GitHub. Let's actually do that as well while we are here. So basically, we want to create a file. I'm adding everything to Git and then basically leave. Meanwhile, if you can see the problem with the approach or in the code, let me know. So we have regions cut by slashes. Let's also create a branch 23rd May and vim. So anyone having any ideas in the comments? The question link is here. It's also on the Discord. Um, all right. So I'm moving forward, guys. Let me add everything to Git, and we will resume this in the next session. I'll figure out what is the problem. I know I messed it up, but I'm having fun solving this problem. So yeah, I hope you're also having fun doing this. There is no like any pressure or something. This is one other problem that we solved, right? 1387. So in 1387, sort integers by the power value .cpp. All right, this is done. What else? We solved one more problem, I believe. No, I think two problems only. Or no, this one also. Minimum number of vertices. Yeah, we did solve this one as well. All right. 1557. Damn it, this is going to take a lot of time. Let's copy it from here. All right. I think I pasted the right code here also, right? Yeah. All right. So this is fine. I'll add three problems again. Um, let's actually add the live stream URL as well. So this is so basically I'm just making sure that the commit is properly having every relevant information. Right? First problem, second problem, third problem, we have added everything. All right, this looks good. This is being pushed. So yeah, you can now go to GitHub and have a look at this code if you want. Meanwhile, I will try to debug this thing. I think there is some problem with the code. I do feel that um, I'm pasting the link to the GitHub in comments for this, so you can have a look over here. But let's see, man, how this goes. Do you have any idea about what's wrong over here? So yeah, Siddhant Khare is saying that they got the approach, but they're not able to implement it. I feel that we were able to implement it, but there is some bug that we have to figure out. We will do that. There is no problem in that. I think one good observation that we did is we did not panic. Like when we were thinking that we should remove these nodes, we very beautifully understood that, it doesn't matter because when you're removing this, it doesn't really count because you're you're decreasing the edge count by 1, you are also decreasing vertices by 1. So eventually this formula stays same. So that simplified things quite a lot. I just have to make sure that, this thing is being properly implemented in the code. And if it is happening fine, then we have nothing to worry about. So Swarnava Das is saying the formula you use is valid only for planar graphs if they are connected. Okay. Oh, so you're saying that the approach is wrong, something like that. I mean, I don't think so because it will still work fine in this one. I think it works for planar graphs, all planar graphs, I believe. Okay, so for any connected planar graphs with V voltage. So we are automatically having connections, right? Is it not the case? Maybe. Yeah, maybe it can happen. Yeah. Maybe it's the problem over here. So basically what they're saying is if I got the comment right, what they are suggesting is it might happen that let's see, if we have something like this, everything is empty, right? Your complete graph is empty like this, and then you just have slashes over here, right? So what they are trying to suggest is this is not a connected planar graph. I think that's what they are trying to say, and that's why the formula won't work in this one. So if you have something like this, the answer for this should be ideally 2, right? Let me complete. So this is the planar graph, but it's not connected, right? And we have one region happening over here, and the other region is the maze. So maybe I'll quickly check if this is functioning or not. But anyways, guys, um, I was not able to solve this one. I will solve this and probably make another video on this one because this problem is really interesting. Um, but yeah, I'll be solving this again and I'll make a separate video for this one once I solve this. All right. So Siddhant Khare is asking how to handle this type of situation in real interview round. So if it was a real interview, I would probably, like I did not need to ask. Maybe the interviewer would have given some hints. If that had happened, then you should be not be panicking out. Like if you're not able to solve, it's okay. Uh, Try to make the best of the current situation and try to see where the interviewer is giving you a hint. Try to follow that direction and try to unlock yourselves. So that's all you can do because it's not happening that there is some magic happening and then you can solve the problem immediately. So yeah, in real interviews, if you are not able to make progress, the interviewers are there to make you like give like throw a bone and basically make you like make some progress. So you have to unlock yourselves, which needs you to stay calm from your mind. I know that if had it been a real interview, I would have also been like not so calm that I am right now, but that's something that we have to practice eventually and be better at. Prashant is saying keep this public. Definitely this is going to stay public. I'm not going to delete this. But yeah, I'll be uploading another video in which we will be solving this awesome problem. So this is more on the grounds of graph manipulation. How do you make that graph and start? Basically, it's a simple manipulation of counting the number of islands in the graph. But you have to do some manipulations on the graph to convert it into a form which you can process and apply that algorithm of counting islands. So that's what we have to do. All right, guys. Do we have any more questions or can we end the stream? So there is some delay in the chat, so that's why I'm waiting for a couple of seconds. If you have any questions, just ask. So someone is asking what are the sources for learning different concepts using graphs for computer programming. I would say you can simply go to Geeks for Geeks and have a look at the different topics and read them. So Geeks for Geeks, graphs. So exactly. So they have this topic, right? DFS, BFS, graph cycle, topological sorting, and basically minimum spanning trees. So give them time. They also have, problems like famous problems like uh, transitive closure or finding mother vertex in a graph. These are not very standard problems, but they have a bunch of problems based on that, a Peterson graph problem and so on. So it's good for you to simply browse through them and get a get some context about what graphs are, and they also have code over there. The explanations might not be that good, it depends, but you always have YouTube and other resources. So if you want to study minimum spanning trees, just simply search some video on YouTube and try to understand what it is. And you can also have a look at the source code. You can also have a look at the source code of all these things in my GitHub repo. So in my library, I have basically a graph section as well. And it has a bunch of code for minimum spanning tree, min cost max flow, Dijkstra, strongly connected components, and all those things. Vicky is asking, would you solve more problems? Yeah, I am. So mostly on weekends, I really plan to solve more problems. Maybe I can do this on my Hindi channel, Developer Bhaiya. If you have not already checked it out, it has 3 videos right now. But it's like basically me talking in Hindi with my audience. So I can do more live streams over there, even in the weekdays. But I do plan to do more such live streams. Um, yeah, I do plan to do that. Someone is asking where to get super concise implementations of CP algorithms. I mean, we have a bunch of GitHub repos. As I'm saying, you have one of them is mine. You can also have other competitive programming repos. I do remember Emacs. There is some website like emacs.ru for algorithms. They also have like implementations. So yeah, cpalgorithms.com. So they also have code, and it's really good. If you want to study, you can use cpalgorithms.com as well. So as I'm saying, they have text as well as code written over here. It is the background for this is basically this is a translation of Emacs website, which was in Russian, and now it's being translated into English, and it's pretty good. I have studied few topics from this as well. Thanks, guys. Some people are saying that it's good we are doing more live problems. They are also enjoying it. That's good. Was there anyone who was able to solve these problems, regions cut by slashes on their own? Pseudoman is asking, how do I remember all these concepts for such a long time? I don't. As I'm saying, like this formula, I had studied this when I was in college. I'm really fond of abstract algebra and discrete mathematics. So I took those extra courses. I'm from electrical science, but I had interest in these courses, so I took them. And like this is how it happens, right? When you are trying to solve this problem and you have some context of like you have dealt with something like that in your past, and then again I didn't remember everything, but I had to resort to Google and figure out what is this. I again made a mistake that this only works for connected planar graphs, which might not be true in our case, I think. So yeah, I do not remember everything, guys. It's I try to be as logical as possible, but there are some times in which you can't remember everything, and this is one of that. All right. All right, guys. I hope you had fun. I really had fun solving this problem, and I'm sure that. So this is one problem that I'm not going to look at the solution. I will solve this on my own. I really love this problem. I do not have any time constraint, or I do not like. I have no time constraint, so I'll be spending 2 days, 3 days on this problem. It's not generally advisable. Like if you are in a like if you are having some constraint time, like you should not even spend this much of time. You should simply go to hints and move on if you are preparing for coding interviews or something, or if you are having some time constraints and you have to make progress. But I am not having any such time constraints, and that's the reason like I'll be spending more time in this problem. Otherwise, in 30 minutes, if you feel that you are not making progress, you should look at the solution or look at the hint. So that's what I would say. So Darshan is asking, do I know trading? It's okay. I've heard your question, Darshan. No need to repeat it again and again. I work in a trading firm, but I work in the risk technology department. I do have gained a lot of information about stock trading because I am working in a fintech space for over 2 years. But I don't consider myself as a pro in that. I have, however, gained a lot of financial knowledge. Someone is asking, am I going to come every weekend? Let's see. For the next couple of weeks, I plan to come even in weekdays. As I'm saying, I might go live on the Developer Bhaiya channel, which is in Hindi. So, yeah. Anything else, guys? Let's take one last question and then let's end this live stream. Last question, guys. Last question goes to Shardul, who is asking, am I in tower research? Yes. And let's end the stream now. Thanks for wasting this opportunity. Uh, Someone is asking, I'm using Python for competitive programming. Is it fine? Yeah, I mean, it's fine. Like if you are just doing competitive programming for your fun and like just a normal hobby, it's fine. If you do, however, want to compete in the top ranks in the field of competitive programming, Python is not the suitable choice. Maybe C++ or Java. However, if you are just simply a web developer trying to, improve your data structure algorithm skills, Python is really good. You should use Python and, don't change your language. It's just too much of hassle and it's not needed. We have Love Bubber on the stream. Hi, Love. How are you doing? Thanks. Are there any Love Bubber fans over here? Shardul is saying, Are aap bhi idhar. Yeah, man. He is here. Yeah, we have never actually. So, this is the first time I'm actually interacting with Love, and that's in a place in which I can speak and he cannot. Maybe I'll connect with him later on. But yeah, I am familiar with his work. He's doing great work in guiding people. Yeah, continue doing that, Love. All right, guys. That's all for this video. I hope you had fun. I'll see you in the next one. Till then, happy coding. Bye bye, and stay safe.